Hello everyone, myself Professor Chavan. We have started the third chapter from our 11th Science CBSE board for the subject physics. In today's lecture, we are going to learn about the calculus methods. Okay. In the previous lectures of the calculation of a area under the curve, we have seen that if there is the irregular profile of the curve, then for that purpose we have to use the calculus method. Okay, but when there is the regular profile and we have the standard formulas for the calculation of the area, then we can use that directly. But in case of a irregular shape of a profile, we have to go for the calculus method. Okay, so calculus is the one mathematical operation. Okay, so we see the calculus is So the calculus is the one mathematical operation in which very minute quantities are measured. Okay, so it has the considerations of a very small profiles. Okay, whenever we have to go for the calculation of a very small quantities, we can prefer the calculus method. Okay, in the calculus method, suppose we have to measure the velocity of a vehicle from the start to within a 1 or 2 seconds, then we cannot calculate that velocity by our proper formulas. Okay, we have standard formulas for the velocity, but how much will be the velocity for 0.001 second, that we cannot measure with the help of our formulas. Okay, so in that case we can go for our calculus method. Okay, this calculus method is again divided into the two operations, that is the differentiation and the integration. Okay, it is divided into differentiation and integration. Okay, so the differentiation is the one part of the calculus method. Okay, but before going to the differentiation, we will see some basic terms in the calculus method, and those are the constant and the variable. Which are the constant and which are the variables? Okay, so if we study minutely, we come to know that the constants are again of two types. The first constant is, it is a quantity which is always constant, means it is not changing in any situation. Okay, in any situation it is not changing. And the second constant is the quantities which are supposed to be constant. Okay, so in a constant, what is the constant? First one, the quantities which are not changing with situation. Okay, which are not changing with the situation. And second, the quantities which are supposed to be constant for that particular situation. Okay, for that particular situation. So we can also call that these are the permanent constant values. Okay, so we can also call them as the permanent, and these are the temporary. Okay, so the quantities or the values which are not changing with respect to the situation, and the quantities which are supposed to be constant for that particular situation. Okay, the constant are of two types. Okay, so in the first case, if we consider, we have the numbers. Okay, we have 0, 1, 2, 3, 4 up to crores of numbers. Okay, so in that case, if we use that number for the particular quantity, suppose I am counting the your marks. Okay, if suppose I am counting your marks, and if I take the sum 1 plus 1 plus 1 plus 1 plus 1, then it will be the 4. Okay, it will be 4. Now from here, if you go to somewhere else and count there that 1 plus 1 plus 1 plus 1, then it will be 4 always. Okay, it will be 4 always. Or suppose in any measuring unit, if you count the number as the weight of one instrument, okay, weight of your body, suppose on any instrument you measure it, then it will be 70 kg or 60 kg. Okay, and on the other instrument if you measure it, it will be again 70 kg or the 60 kg. Okay, so the numbers are not changing with respect to the situation. So that's why all the numbers are coming under this first category of the constants. Okay, all the numbers from 0 to further are coming under the category of the constants. Okay, then if we consider some constants are there, like the value of pi. Okay, what is the value of pi? It is 3.14. Okay, value of pi, it is 3.14. So we are considering the value of pi is equal to 3.14 or 22 upon 7 as per our convenience. Okay, so value of pi is permanent. It is not changing with respect to the situation. Okay, it is not changing with respect to the situation. So that type of constant is coming under the first category. Okay, it will come under the first category. Now suppose if we consider one more constant like the acceleration due to gravity. Okay, the value of the acceleration due to gravity, g, is always equal to 9.8 meter per second. Okay, g we are always taking it is equal to 9.8 meter per second. That is, you go anywhere or in any place on this earth, the value of the g, or the constant all over the earth, all over this world, that is 9.8. Means this is the one constant which is having the value permanent. Okay, it is having the permanent value. So that why this constant are also coming under the first category, that is quantities which are not changing in any situation, and that's why we can also call them as the permanent constants. Okay, now the second, that is quantities which are supposed to be constant for that particular situation. Okay, suppose we take the example of a vehicle traveling with a uniform speed of 20 km per hour. Okay, then in that condition, what is the constant? I am telling you that one sentence is there that it is traveling with a uniform speed of 20 km per hour. Okay, so in that case, the speed of the vehicle is the constant for that particular vehicle only. Okay, in that case, the speed of a vehicle is constant for that particular vehicle only. But what is the changing there? The position of a vehicle changes because it is traveling from one position to the another. Okay, it is traveling from one position to the another. So in that, the position is changing. Okay, so what is the constant in this vehicle? It is the speed, its uniform velocity of 20 km per hour. So it is for only that particular situation, only for that particular example. Okay, the quantities which are supposed to be constant for that particular situation only, means they are temporarily constant, not the universal constants. Okay, not the universal constants. Okay, so 20 km per hour is the uniform speed of that vehicle. So in this example, the speed is the constant. But now if I give you the example of a one truck traveling some soil in it. Okay, so the truck full of soil is going with a speed of 40 km per hour and it is traveling for the 1 hour. Okay, then in that there is the some quantities like suppose there is some leakage and the mass of the that soil, also there is the leakage like the 50 gram per second. Okay, suppose there is a leakage by the rate of 50 gram per second, then in that situation what is the changing? What is changing there? The mass of a truck changes. Okay, and in the first example, when the vehicle is traveling from the with the uniform speed of 20 km per hour, then in that case the mass of a vehicle is constant. Okay, mass of a vehicle is also constant. But in the second case, when the truck is traveling with some speed and it is traveling for the 1 hour, and during that 1 hour suppose there is the leakage of the soil by 50 gram per second, then there is the change in the mass of a soil, there is the change in the mass of a truck, because there is the leakage of the soil. Okay, as there is the leakage of the soil, so during the 1 hour period the soil will get leaked by some quantity. So in this case the mass is of the truck is not constant, because there is the leakage. Okay, mass of the truck is not constant, but what is the constant here? The truck is traveling with a uniform speed. Okay, truck is traveling with a uniform speed of 40 km per hour, and for the 1 hour it is traveling. Then what is changing here? The mass of the vehicle changes here, because there is some leakage in the soil, there is some leakage in the truck. So in the second case the mass is changing. So the quantities are supposed to be constant as per our convenience, and that values are coming under the second category, that is the quantities which are supposed to be constant for that particular situation only. Means for that particular example only the quantities are supposed to be a constant. Okay, now this is about the constants. The constants is divided into the two quantities, that is the permanent constant and the temporary constant. Now we have to see for the variables. Okay, we have to see for the variables. So the variables are the values, are the quantities which are supposed to be, can be have any variable value. We can assign any variable value to that particular constants. Suppose the vehicle is traveling, then in that case what is the changing there? The position is changing. Okay, the position of a vehicle is changing. Now any motion or the any activity contains the two variables. Okay, any activity contains the two variables. Although the vehicle is traveling, then in that situation we can easily get that the position is changing. Okay, the position is changing, but along with the position there is also the change in the time. Okay, there is a change in time. So in that case we can say that the position is also variable and the time is also variable. Now any motion or the any activity contains the two variable, out of which the one is the dependent variable and the second one is the independent variable. Okay, so in this situation when the vehicle is traveling, then there is the change in position, but how? With respect to time. Okay, so we can say that the position is the dependent variable. Okay, if we write here the variables, in case of a variable it is either dependent or second independent. Okay, the variables can be dependent or the independent. The position is dependent on the time, because time is not depending on any variable. So that's why we can say here that the time is the independent. Either we want or not, the time always goes on. So when there is a change in position, there is a change in the time always. So time is the independent variable and the position is the dependent variable. Okay, suppose in case of mathematics we are always taking some variables like x, y, z. Okay, we are taking such letters as a consideration, like let this value be the x, let this value be the y. Okay, so for our purpose we are considering that some variables there, the x, y, z. Okay, and as per our problem, as per our numerical, the value of the x can be anything as per our requirement. So we can assign any value to that particular variable, and that's why these are called the variables. Suppose in mathematics we are having the equation like y is equal to, we have the value y is equal to 2x square minus 3x. Okay, we have the equation like y is equal to 2x square minus 3x. So in this case, which is the dependent quantity and which is the independent quantity? If we go for this, then we come to know that the y is the dependent quantity and x is the independent quantity, because the value of y completely depends on the x. Okay, the value of y completely depends on x. So if we put x is equal to 1 here, what do we get? 1 square minus 3 into 1. So we will get 2 minus 3 is equal to 1. But when we keep x is equal to some 3 here, okay, then in that case we will get 2 into 9, 18 minus 3 into 3, 6, we will get y is equal to 12. So we can see that when we change the value of the x, we are getting the value of the y with respect to that quantity. Okay, so in that case we come to know that y is the dependent variable of the x, or we can write it as the y is the function of x. Okay, we can also write it as y is equal to function of x. Okay, y is the function of x. But in this case we have to remember, don't have to forget that the 2x square minus 3x is not the operation. It is not the one operation, because operation is the another part from the calculus. Okay, so this is just one example I am giving you, that 2x square minus 3x is one equation given and which represents the value of y. The value of y completely depends on this equation, because whatever the value we assign to the x, accordingly the value of y changes. So we can also say that the value of y is the function of x. Okay, the y is equal to f of x. Okay, so y is equal to f of x is the one function and it is not the one operation, because operation is the another part in the calculus. So we can say that y is the function of x. Suppose we have the value like z is equal to 3x cube minus 5. Okay, we have the value z is equal to 3x cube minus 5, then we can say that z is the function of x. Okay, here again we can say that z is the function of x. So we can assign any value of x to any value of the any variable. Okay, here y is also variable, x is also variable, z is also variable. But what is the situation, that as per the condition given that z is equal to something in terms of the x, then the independent and independent, that terms changes here, because in this case z is the dependent and x is the independent. Okay, suppose we have the another value like x is equal to cos of theta. Okay, if we have the value that x is equal to cos of theta, then here we can say that x is the function of theta. Okay, we have to consider that x is the function of theta, and in this case x is the dependent variable and theta is the independent variable. So according to the situation, this terms changes, which one is the independent and which one is the dependent variables. Okay, so from the variables we can learn that we can assign any value to the variable, and that's why there are number of values for the any variable. So here I will use one term, that is the operation. So what is the operation now? Okay, what is the operation? So this is about the constant and the variable. Now what is the operation? So in a calculation, there are some operations also. Okay, so generally we are aware of the 4 operations, that is the addition, subtraction, multiplication and division. But if we go too much basic, then we come to know that the addition and subtraction are only the 2 operations. Okay, these are the only 2 basic operations, and multiplication is the part of the addition and the division is the part of the subtraction. Because when we go for the multiplication, then what we are doing, suppose we have to multiply 4 into 4, then what we are doing, that we are adding the 4 for the 4 times, then we are getting the 4 into 4, that is the 16. Okay, if we have to go for the some division like 30 divided by 3, then what we are doing, we are subtracting the 3 from the 30 by the 10 times, then we are getting that particular value of the division. Okay, when we are going for the multiplication, okay, in the operations, 2 basic operations, addition and the subtraction, addition and subtraction. Okay. And depending on this, we have to go for the multiplication and the division. So multiplication is nothing but the addition. Okay, in the multiplication, when we go for 4 into 4, it is nothing but the 4 plus 4 plus 4 plus 4. Okay, and in the division, what we are doing in the division, we are going for the subtraction, means from the 30 minus 3 we get the 27, minus 3 we get the 24 minus 3. So we have to do this the 10 times. Okay, we have to do this 10 times. That is, what is the basic between the multiplication? It is the addition. And what is the basic between the division? It is the subtraction. Okay, so when we have to go for such a operations, then we have to remember that we are going nothing but for the addition and the subtraction. When we go for the any operation, then we are going for the comparison of the two quantities. We are going to operate that two quantities. Suppose we have to count the velocity of the one car which is in a motion. Okay, then in that case we have to consider how much will be the displacement of that car for the particular time period. Suppose we count the displacement of that car for the particular time period, then if we divide that displacement by the time, we will get its velocity. Okay, we get its velocity. Suppose for the 0.1 second we have to count the velocity, then what we are doing, we are just calculating how much is the displacement of the car in a 0.1 second, and we are going to divide that displacement by the time, and we are getting the velocity. Suppose for the 0.2 second we have to count the velocity, then in that case again we are counting the displacement and we are dividing it with respect to our time, then we are getting that velocity. Okay, now this can be done by some readings, but what in case we have to count the velocity of a body or the car in 0.001 second, then how can we calculate it? Suppose we have to count the velocity of a rocket for 0.001 second, then how can we calculate it? Or for 0.002 second, then how can we calculate this? So for that process, the calculus method is very much important. Okay, for the measurement of the very small quantities, the calculus method is very important. Okay, suppose we have the one values of the x and y, in which the x is the variable and y is the function of x. Okay, suppose we have the function in which x is a variable. Okay, x is variable and y is equal to f of x, that is y is the function of x. Then from this we can say that when x is equal to then we can say the y. When x is equal to x1, we can say that it is the y1. When x is equal to x2, we can say here it is the y2. Okay, because what, as the x changes, the y also changes, because y is the function of x. Okay, because y is the function of x, so as the x changes, the y also changes. But in this case it is very simple. But when we have to go for the very smaller change, suppose very small change in the value of y we have to calculate, then we have to use the calculus methods. Okay, we have to use our calculus method. Then when we have to calculate very minor change in y, with respect to x, calculus method can be used. Okay, calculus method used. So which method is used? Which calculus method is used? We will see now. Okay, we have seen there are two calculus methods, out of which one is the differentiation and another is the integration. Okay, so out of that, which method can be used here for finding out the very minor change in the y? Okay, what we have to find out? We have to find out the change in y with respect to x. Okay, so if we take the ratio of this, the change in y upon change in x. Okay, change in y upon change in x. Okay, suppose we plot it on the xy curve, on the xt curve, then we will get, suppose this is the one curve in this, when x is equal to x1, y is equal to y1, when x is equal to x2, y is equal to y2, and now we have to count the value of y at the particular instant of x. Okay, we have to count the value of y for the particular instant of x. Then what we have to do, we have to project one projection from this on this inclined line. Okay, on this inclined line we have to project this. So at this point here will be the value of y. Okay, here we will get the value of y. Here is the y1, here is the y2. Now from here we will get the value of y, but how much will be that value? There must be as possible as low error, or the value must be approaching to the real value. So for that purpose what we have to do, we have to consider here one slope. Okay, we have to take the slope of this current position of the y. Okay, then we will get the value of y. Suppose we consider here one slope. Okay, then in this case, by calculating the value of the slope, what is the slope in the curve? It is nothing but the tangent. Okay, the slope in the curve is nothing but the tangent, and tangent is given by perpendicular upon base. Okay, the tangent is given by perpendicular upon base. So in this case, what is the slope? Slope is equal to what is perpendicular upon base upon base. Okay, so what is the perpendicular in this case? If we count, here will be some value of y, here will be some value of y. So if you take the subtraction of the minor value from the major value, then it will be the perpendicular. And in case of a base, if we consider here, it will be very minute value, that is x2. Suppose here is the x2, here is the x1, then x2 minus x1 will give us the very minute value. So perpendicular is nothing but equal to y2 minus y1 upon x2 minus x1. Okay, the y2 minus y1 upon x2 minus x1 will give us the slope. Okay, will give us the slope. Then and then only we can find out this exact value of this y. Okay, we have to consider this triangle as much as smaller possible, because when we reach the smallest value of that slope, we will get the exact change in the y with respect to x, because change in y with respect to x will give us the maximum correct value of y. Okay, because y is the function of x. So in this case, slope is equal to perpendicular upon base. If we write down this y2 minus y1 upon x2 minus x1, for the smallest value of y, we can also write it here, the delta y. Okay, delta y upon delta x. So our slope is equal to delta y upon delta x. So in this case, what is the delta x? It is the very smaller value, and for the very correct value of y, what we have to consider, that the value of delta x is such that after considering that value, if we further go for the smallest value, then that is almost equal to 0. That is, delta x is almost equal to 0. For the exact or correct value of delta y, what we have to consider, the delta x is almost equal to 0. That is, it is approaching the 0. Okay, then we will get the exact value of y there. Okay, so for the exact value of y, what we have to consider, the delta x almost equal to 0. And to put that, we have to write here that equation as the taking the limit. Okay, we have to take here some limit, then we will get the rate of change. Okay, so rate of change, we can write here, rate of change is equal to limit delta x tends to 0 delta y upon delta x. Okay, limit delta x tends to 0 is delta y upon delta x. Now if we go for this, then we can write it as, instead of limit, we can write it as the dy by dx. Okay, so instead of this, we can also write it as the dy by dx. The rate of change is equal to dy by dx. So what we are doing here, we are calculating the exact value of the change in the physical quantity with respect to the change in the basic quantity. Okay, we are taking the rate of change in the physical quantity with respect to the change in the basic quantity. What is the basic quantity here? It is the x, and what is the physical quantity we are calculating here? It is the y. Okay, so the dy by dx will give us the rate of change, or we can also call it as the derivative of the x, derivative of the y with respect to x. Okay, we can also write it as the derivative of y with respect to x, or we can also call it as the differentiation of y with respect to x. Okay, so in the method of calculus, it is termed as the derivative of y with respect to x, which gives us the exact significant value for the y with respect to change in the x. Okay, which gives us the exact change in the value of physical quantity with respect to the basic quantity. Okay, so here in this case what we are doing, we are combining the division and the subtraction. Okay, because if we see here, this operation is nothing but the subtraction, this operation is nothing but the subtraction, but what we are doing the conversion of the subtraction into the division. Okay, we are taking the conversion of the subtraction into division, and we are getting delta y by delta x. Okay, we are getting delta y by delta x. So here it is delta y by delta x, it is nothing but the one division operation. Okay, it is nothing but one division operation. So accordingly we can say that the combining the division and the division and the subtraction, we are getting the operation of the differentiation. Okay, for the operation of the differentiation, which is one of the calculus method, the two operations are combined. One is the division and second one is the subtraction. Okay, so combining these two operations, we are getting the one of the method of the calculus, that is the differentiation. Okay, so in the differentiation we can say here that we can combine the division and the subtraction. Okay, so from these two cases we can say that we are getting the exact significant value of the y with respect to x. We are getting exact significance of y with respect to x. So this is about the differentiation, which is the one of the method of the calculus. Now if we go for the significance of the differentiation, that is why this term is possible, that this term is true, how we can give the significance of the differentiation also. Okay, because on which basis we can say that this is the true. Okay, so for that purpose we will give the significance of the differentiation. Okay, what is the significance of differentiation, or how we can give? So in the differentiation we have seen that it is nothing but the dy by dx. Okay, it is nothing but the dy by dx. So in that case we are considering that the delta x, the difference between the basic quantity, is almost approaching to 0. Okay, it is almost approaching to 0. So in that case, how we can prove this, that when the delta x is almost approaching to 0, we are getting the exact value of dy. Okay, so for that purpose, if we draw one curve, okay, if we draw one curve, then in this curve, if we have this curve, okay, and here is our value of, okay, this is the x2, this is the x1, okay, this is the x1 and this is the x2. Okay, then in this case, if we draw a secant, which is, secant means what? A line passing through the circle. Okay, it is nothing but the secant. If we draw a secant almost passing through x1 and x2, the points x1 and x2, then it is, if we take the difference in this case, then we will get the larger difference. Here if we take x2 minus x1, it will be a large value. Okay, it will be a large value. So if we reduce the value, so for that purpose what we have to do, this x2 we have to consider nearer to the x1. Suppose if we draw another secant here which is passing through this, okay, then at that case here will be our value x2. Okay, here will be our value x2. So in this case, if we take the x2 minus x1, it will be slowly decreasing. Okay, this difference is slowly decreasing. So now if we draw the secant like this, then in that case what we have can consider, in this case what we can consider, the value of x2, in this case the value of x2 is almost approaching to the, almost equal to, okay, x1, okay, the value of x2 is almost approaching to the x1 when the secant is almost tangent to that curve, okay. So when the secant is almost tangent to that curve, we will get the very minor difference, okay. This value x2 minus x1 is a very minor when secant is equal to the tangent, okay, when secant is equal to the tangent. And we know what is the tangent mean any VT curve or any XT curve. What is the tangent? Tangent is nothing but the slope, okay. So tangent is nothing but the slope. So we can say here the difference x2 minus x1 is very small, then in that case the secant becomes the tangent, and we can say here tangent is representing the slope, okay, tangent is representing the slope. And we have seen that slope is nothing but the perpendicular upon the base, okay, slope is nothing but the perpendicular upon the base. So in that case, if we consider the perpendicular as y2 minus y1 and x2 minus x1, then our slope is there, okay. We have to consider here y2 minus y1 and x2 minus x1, okay, y2 minus y1 upon x2 minus x1. This will give us the value of slope, okay. So when it is possible, when the secant is almost the tangent of that curve, okay, and when it is possible the secant is almost tangent to that curve, that when the x2 minus x1 is very very small, okay, the difference x2 minus x1 is very very small. So when we are getting the very small difference, that is it is almost approaching to the 0, then we can say that we can differentiate that y with respect to the x. Our value will be equal, and we will get the exact value of the y with respect to the change in the x, okay. So for that purpose we have to assume that the delta x is almost approaching to the 0, and we have to consider the limit there, that is the rate of change is equal to limit delta x tends to 0 d delta x upon delta y, or we can say it as the dy by dx, or we can also pronounce it as the differentiation of y with respect to x, or we can also say it like the derivative of y with respect to x, that is the differentiation, okay. This is the differentiation. Suppose we have the one VT curve, okay, suppose we have the VT curve, and in that VT curve we have to find this slope, okay, we have to find this slope. Then in this slope, which value we are getting? We are getting the acceleration, okay. So when we find the slope in the VT curve, we are getting the value of the acceleration, okay. So when we can get the exact acceleration at that particular time, okay, when we can get the exact value of acceleration at that particular time, we have to take this slope, and in that case again the value of the delta v upon this delta t, okay, the value of the delta v and delta t must be almost very low, okay. So when this value delta v and delta t are high, we are getting the exact approximate value of our acceleration, okay. So when this delta v and delta t are high, we are getting the approximate value of our acceleration, and to get the exact value of the acceleration in that particular motion, what we have to do, we have to consider this delta t is almost approaching to 0, okay. This delta t is almost approaching to 0, and for that purpose, as the delta t is almost approaching to 0, we have to consider a very smaller difference between the v2 minus v1, okay. We will get a very smaller difference between the v2 minus v1, that is the change in the velocity, and as it is that change it with respect to the time, we are getting that the exact acceleration, okay. So what is important in the any slope or in any derivative, that this difference must be a very minor value, or must be any instantaneous value, okay. When delta t is almost approaching to 0, delta t almost approaching to 0, we get instantaneous velocity. As we have learned this instantaneous velocity. Okay, we get the instantaneous velocity. So we can get exact value of acceleration. Okay, exact value of acceleration. Okay, we can get the exact value of acceleration there. So for any calculation, it is very important that we must consider a very minor difference there, so that if we take the derivative of that terms, then we will get the exact value of that physical quantity. So what is important to find out the any physical quantity, that we have to consider the any one value almost approaching to the 0, and depending on the two physical quantities relation, we can get the exact value of the third physical quantity. Okay, so from this we will get the exact value of the acceleration. Now there are also number of quantities which are dependent on each other, like if we consider the force is equal to energy upon displacement. Okay, force is equal to energy upon displacement. Then in that case, u is the variable and x is the basic term. Okay, u is the variable and x is the basic term. So as the x changes, we are getting the value of the u. Okay, we are getting the value of the u, and accordingly we will get the value of the force. To find out this particular value of the force, what we have to consider, that there is the very minute displacement of the particular object. Then when we consider the very minute differentiation of very minute value of the delta x, very minute value of the displacement, then we will get the exact value of the energy there, and when we take the differentiation of these two values, we will get the exact value of the force. Okay, so to get the exact value of the any physical quantity, the differentiation is a very important calculus method. Okay, to get the any exact value, we have to use the derivative of that particular physical value with respect to the change in the basic value. Okay, so what is important in the derivative is that we have to consider the very minute change in the basic quantity, and accordingly we can get the very minute change in that physical quantity. Okay, that is we have to go for the differentiation for getting the exact value for that particular physical quantity.